Okay, so limiting reactant problem. Without doubt, limiting reactant is the most complicated problem we'll see from this chapter. And there's really just one other issue we want to talk about with respect to these calculations that go along with balanced equations. And that is percent yield. So the reactions and the calculations we've looked at so far, we kind of assumed every particle of reactants becomes product. So every single atom that's part of the reactants ends up being part of the products. And when you do a reaction in a laboratory, they don't always work perfectly. In fact, they probably never work perfectly. So you end up with some of your starting materials unreacted, or you get byproducts that are other things. So we often want to compare that real result you would get for how much product, say, you would produce in a reaction to how much product could you get if the reaction was perfect. And that's really what we're looking at in percent yield. So percent yield is what did we actually get out of a reaction. So it would be the actual yield, right? And you could do this in grams or moles. Normally you're going to do this in grams, right? What mass did you get for the reaction? And we're going to compare that to what's called the theoretical yield, or how much could you get if the reaction was perfect. And you want to measure that in the same units. So those ratios in grams would be the same as those ratios in moles. If you don't, if you just have moles, then that would work. And like any percent, this is scaled to 100. So if you know what the actual yield is, you just have to calculate the theoretical yield, and you can figure out, well, what percent yield that was actually produced in that reaction. And that's kind of what we're going to do in the sample. So it's a reaction we've looked at before. Propane burns in oxygen, makes carbon dioxide and water, right? Now we start with 45 grams of propane, sufficient oxygen. So that means no limiting reactant. The limiting reactant is going to be the propane because we've got plenty of oxygen to do the reaction. We react 45 grams of propane. We produce 104 grams of CO2. We want to calculate the percent yield. So this 104 grams of CO2 is the actual yield. So this is what was actually produced. We need to figure out, right, theoretically, how much CO2 could we have made. Then we can calculate the percent. So starting with 45 grams of propane, we want to calculate, well, how much CO2 could we make if the reaction was perfect? So starting with grams, we want to convert to moles. Now propane is 44.11 grams in a mole. We did that a couple pages back. So again, if you don't remember that, that's not something you should have memorized, but you can always find that in your periodic table. From moles of propane, we can look at our balanced equation. Now we're comparing CO2 here from our actual yield to our theoretical yield. So 1 mole of propane reacts to produce 3 moles of CO2. We put the propane on the bottom because that's the unit we're trying to cancel out. We put the carbon dioxide on top, 3 moles of carbon dioxide. Now, since we're comparing to a mass, we do want to go back to mass here. So I want the molar mass of carbon dioxide. So let's calculate that. There's 1 carbon, that's 12.01. There's 2 oxygens, each one is 16, so that would be 32. So that's 44.01. So there are 44.01 grams of CO2 in a mole of CO2. So that would be the theoretical yield, how much we could have gotten from this reaction. So 45 divided by 44.11 times 3 times 44.01. And that is 134. Now we really just have 3 significant figures here, but since this isn't the final answer to the problem, I don't want to round off too much. So I'm just going to keep some of that extra information. Right? In fact, if you know how to use your calculator, you can just keep that number in your calculator and use it in the next step. Okay, that's our theoretical yield. we want to compare that to the actual yield. So again, percent yield is going to be actual over theoretical, and then multiplied by 100. So if our actual was 104 grams, our theoretical is 134.694 grams. Grams is going to cancel out like it usually does in a percentage. And we're left with, and again, we just have 3 sig figs, so this one I'm going to round. 77.2% would be the yield for the way this reaction worked out. Okay, that is the end of chapter 3. So we'll stop the video there, and we'll come back with chapter 4.